Hello and welcome everyone to my session on how and why to upgrade to Java 16 and 17. My name is Johan Janssen and I work for Sanoma Learning. So the agenda for this session, first we're going to look on why you should actually upgrade your application to the new version of Java. Then we'll talk a bit about the new release cadence of Java. After that, we're going to dive a bit deeper into how you could actually upgrade your application, and then the step-by-step guide on upgrading each Java version and the challenges and solutions for that. If you have any questions, feel free to reach out to me via LinkedIn, Twitter, or have a look at my GitHub page where actually this presentation is based upon. On the GitHub page, I describe various issues and the solutions for those challenges in Java. So it's quite a bit of information. You can see some detailed background information, but also some of the things that changed, errors that you will get if you haven't fixed it yet, and the solutions for that. So if you look at this GitHub repository, it will help you a lot when upgrading to the new versions of Java. A little bit of background information. I didn't get all this information by Googling. I actually have a lot of experience upgrading to various versions of Java over a lot of years already. I've done that at various companies, lately upgrading to Java 16 and 17. But still, of course, if I encounter any issues, Google still is my best friend. So if you have any challenges, again, Google will help you, but this presentation, I hope, will give you a basis to get started so that you don't have to Google for every issue and be a bit more productive. First, the reasons why should you upgrade. Basically, because you get a lot of things for free if you actually upgrade your application to the new version of Java. You get performance improvements, security fixes, but also the cool new features such as pattern matching, records, and all kinds of useful productivity features. Another good reason, I think, is to keep your application up to date because it helps you to keep and attract new employees, which is quite a challenge nowadays with the high demand. But there are also some reasons why upgrading can be a bit of a challenge and it's sometimes postponed or even not done at all. Because it's not only updating your laptop, it's also updating the build servers, the production environments, and everything. Another reason why a lot of companies are still waiting with upgrading to new versions of Java is because they think that the upgrade to Java 9 with the module system or Jigsaw takes a lot of time. Actually, you don't even need to use the module system. So you can perfectly upgrade to Java 9 or beyond without using any modules. So that works perfectly fine. Another reason some of you might have a bit of a trouble upgrading is because you run software at client machines, and those client machines only run on an older version of Java. So that prevents you from upgrading. Actually, there is a bit of a solution for that. And nowadays, with the multi-release jar feature, you can actually have multiple versions of Java code in the same jar file. In this example, we have some code which is based on an older version of Java in the Java directory, and we have some Java 17 code in the Java 17 directory. So let's see how this looks like within the IDE. If we look at the example, we have a normal traditional student class with an isBlank name where basically first name is checked if it contains any blanks. Then we have the same basically class, only this time it's a record, which is in the Java 17 directory, and it contains the new string.isBlank method, which is provided in one of the newer Java versions. We also have an application class, which basically prints the version of Java currently used. And further, it also prints the implementation. So if it's a class or a record, and a few checks to see if the provided students contain a blank or not. We also need a bit of configuration for that. We need to specify in the POM file or in your Gradle file which compiler levels should be used. So we compile the normal code in the Java directory with Java 8, and we compile everything in the Java 17 directory with Java 17. For the rest, it's relatively simple. I use an application main class to make sure that I can run the jar file automatically. And I have a Docker file, which basically enables me to build and run everything. So we need to build it on the newest version of Java, which we specify in our code base. In our case, that's Java 17. So we use a Maven Java 17 image to build the application, and then we run the jar file. Then we copy the jar file to a new Docker image, this time based on Java 8, and we again run the application. And as a third step, we run it on a Java 11 image. So let's see how that goes. So I have some caching features in it, basically to make sure that I don't have to download everything every time, but feel free to remove that to make the solution a bit simpler to work with Docker. This is just a bit easier for my presentation. So if you look at what happened here, first the application is being run on Java 17. We see that the record feature is being used, and we see some of the student prints. Then the application is run on Java 8. We see that the Java class is being used and the rest of the information. And as the last step, we see that Java 11 is used and it still uses the class. So we see that basically the traditional student class in the Java directory is used for all Java versions until Java 17. On Java 17 or higher, the implementation in this directory is being used. So that way, you can use multiple versions of Java in the same jar file. But be careful, because it's a little bit tricky. If you have the student class, it should have the same public interface for each Java version you're using. If not, you will have some runtime issues. And in fact, if you build it with Maven, Maven doesn't use the jar tool to build the image, and it won't give you any warnings. So basically, Maven will build it perfectly fine for you if you forget to add the same public methods to all the classes for all the Java versions. You will have some runtime issues when you run it, which is a bit annoying. Luckily, I've seen that within the IDE, in my case, IntelliJ already provides a warning if you do not specify all the public methods. So I think it's a useful feature maybe to have some performance improvements with newer versions of Java and the performance benefits they offer for some parts of the application, but really be careful with it and don't implement your complete application in 3 different versions of Java, because maintenance will be quite tricky. So it's a nice solution for, I think, some corner cases, but be careful with it. One thing I'm quite happy with is the way we use Docker within our company. So we use Docker in both the build environment and the production environment, and that makes sure that each team can specify their own Java versions. They don't need to have some central operating team to install new versions of Java on the build server or on the production machine. They're free to do it themselves. So every team can migrate at their own pace, at their own convenience. So that's, I think, a good benefit of the abstraction layer that Docker is providing. If you don't use Docker and you have more traditional build servers and production machines, then it might be a bit of a hassle, because you need to install Java versions manually, which is sometimes a bit more cumbersome. Of course, it's still doable, and I think you should still do that. So why this session? A lot of people, I think, they see upgrading to a new version of Java as a big challenge. It's often really overestimated. And so I've heard estimates of weeks to months for an upgrade from Java 8 to Java 11. When I did that actual upgrade, it took me just a couple of days. That was partly because of my experience, but also for a large part because I simply got started and there are a lot of unknowns. It's simply just do it and see what kind of issues you encounter, depending on how challenging your code base is, how many dependencies you use, how many strange features that you use. It might be more or less work, but really try not to overestimate it, because then probably your management and the business, they will postpone it because there are other more important things to do and there's not enough time for that. Simply get started. Personally, I like to do this on like a Friday if I have my hours finished. Just spend a little bit of time selecting a new Java version and see what things crash. If you're lucky, for instance, I did a migration to Java 16. I only encountered one issue, I fixed it, and then it was done. So it can be quite easy. It's simply a matter of getting started. And I really hope that this session helps to get more applications on Java 16 and Java 17 once that's released. So it's a bit of a challenge, but we'll help each other to make that challenge a bit easier. Because I've seen that a lot of the challenges that we face when upgrading applications are the same for all applications, or at least for a lot of applications. So I try to help you with those issues so that you can focus on the issues that you have that are application specific. For the examples, I use Maven, which can basically do this in any build tool. So let's go on this challenge together because it's hopefully more fun and it's easier for you. So for Java, before Java was released like every 3 or 4 years, nowadays it's released every 6 months. So every 6 months we have like a normal release, and every 3 years we have a long-term support or LTS version. The current one is Java 11, and the next one will be Java 17, which is released in September. The big difference is that for the normal Java versions, minor upgrades are only released until the next version is available. So that's for about 6 months. LTS versions receive minor updates for a longer period of time, at least until the next LTS version, but often a lot longer, depending on the vendor, which JDK you're using. So what to do then? Should you stay on the latest version of Java, or should you stick on LTS versions? I think you have to ask yourself, are you able to upgrade every 6 months? And do maybe a bit bigger upgrade every 6 months. Because if you're not able to do that, then you might no longer be able to do the minor upgrades as well. While if you stayed on the LTS version, you can happily upgrade to minor versions for a couple of years. So I think it depends a bit on the company and also on how interesting are the features that are being released. If Java 18 releases some really cool features, then maybe people are more eager to upgrade to that one and stay on the 6 months releases instead of on the LTS versions. So actually, what do we have to upgrade? A normal application consists of some application code and some dependencies. And underneath that, Java or the JDK is running. So if something is removed in Java, you basically need to either upgrade your dependencies, change some application code, or maybe both. And then it helps to have a bit of patience. If you wait until the dependencies already fixed the issues, then you can simply upgrade the dependency and you're good to go. You don't need to do much yourself. And if we talk about deleting stuff inside the JDK, then actually it's often not immediately deleted, it's being deprecated first. So if you look at JuxB, JuxB was a normal feature before. In Java 9 and 10, it was marked as deprecation or marked for deprecation. So basically, you already got a warning in your IDE and you could already fix the issue. And in Java 11, it was finally removed. But if you fixed it before, then basically the removal doesn't have an impact for your application. So what kinds of things are then actually being removed? It can be basically anything, from methods to complete tools. Anything can be removed within a Java version. Then how can we see what's actually being removed? We can look at the Java Almanac website. Let's have a quick peek on that one. So the Java Almanac website can be used to compare different versions of Java. In this case, Java 17 and Java 8. And we can see which methods are being removed and added. Fuj offers something comparable, also based on the Java Almanac, which can also be used to see what's changing in various versions of Java. This is more like a reference. Don't try to basically read through this. It can be relatively boring. I didn't read through it before upgrading, but I can sometimes use it when I get strange compile errors. Then I check if methods are removed or if there are alternatives for those methods available. So it can be quite helpful. Other very interesting sources for information are the OpenJDK website and the Oracle release notes. So let's also have a quick peek at those. So the website for the OpenJDK, let's actually look at Java 17. It specifies which Java enhancement proposals or JEPs are being targeted for this Java release. So you can see on a high level which features are being added, deprecated, or removed. If we want to have a bit more detailed information, we can look at the release notes per version, and we can see in detail what's being changed. So we can even see which certificates are being removed, etc. So again, this is very helpful as a reference. You don't need to memorize all the information in this slide deck or in this website. So if you upgrade Java to a new version, it can be quite helpful to have multiple JDKs running. One so you can continue your normal development, and one so you can upgrade to the latest version of Java. And there are actually a few ways to do that. They are mentioned here. I've used Docker in the examples, but Docker has a bit of a longer feedback loop, so I wouldn't start with that, but Docker can be quite helpful to test some things on various versions of Java, or to make sure that it's running on a clean environment instead of your local environments, which might contain all kinds of personal settings or changes that you made. If you want to run the Docker examples or run your own project in Docker, it's relatively easy. You can simply create a Docker file like this. I made sure that it only fails at the end so that I can see all the information that Maven is giving and that it doesn't stop at the first error. And then I run the command docker build -t. I give it a name and I specify the dot. Don't forget the dot. It specifies the context, in this case, the current directory. Without it, it won't work. And then it's time to start working, starting with the local machine and the build environment. And in the end, we go to the deployment environments. Sometimes when you then encounter an issues, it can be like a needle in a haystack. And then it might help to upgrade Java versions one by one. So for instance, from 8 to 9, from 9 to 10, instead of from 8 to 11 at once. Because if you do that and you encounter any issue, you don't know which version of Java has caused it. And it's often a lot helpful if you know the exact version, because then you can include that version when Googling for the error. So it might be good to, if you have a lot of issues, to make smaller steps with the upgrade process. So let's have a look at the ingredients. First, of course, it's really helpful if you have an IDE with proper support for the Java version you're upgrading to, because then you already get all the feedback inside your IDE and you can fix issues there and have a really short feedback loop. But don't forget to also upgrade all your build tools and the plugins they're using, because else some parts might still be running on an older version of Java. For Maven, it's relatively easy. We specify the release to 17, and we can run everything with Java 17. Be sure that you also upgrade your dependencies. There are various reasons for that. Again, security fixes and things like that. But the other big advantage, of course, is that they support the newer versions of Java. I, in general, try to do this on the old version of Java. So first upgrade all the dependencies to the latest version, check if everything still builds and runs, and then upgrade Java to a new version. One thing to keep in mind is that you don't only need to upgrade to the new versions of your artifacts, but also see if they changed the names, which you will see in a moment. To find out if you have any new versions for your dependencies, you can either use the Maven versions plugin or the Gradle versions plugin. And so we start with steps, and I really recommend that. Make sure you don't try to do everything at once, because then you can also show progress to your teammates, to the business, that you're making steps towards the solution. So first try to compile your source code, then run your unit test, or maybe even first compile your unit tests. Make sure you package your application and then test the running application. If you're lucky, you can do this step by step. Sometimes it's a bit more difficult. I've encountered that if I wanted to upgrade dependencies, that the dependency required a newer version of Java. So I basically had to do the upgrade of the dependencies and the upgrading of Java at the same time. And then it's a bit more cumbersome to figure out if either the dependency or the Java upgrade is causing the issues. So let's look at the various Java versions. In Java 11, a lot of things have been removed. One of them is JavaVex. There are various ways to still make sure you can run JavaVex. Either use a separate build for that, the dependencies, or use a JDK which still contains them. So the normal specification and the OpenJDK no longer contain JavaFX, but there are vendors who offer builds with more inside it than only the stuff that's specified. For instance, the Liberica JDK has a full JDK with a lot of extra stuff in it, and the same goes for the OJDK build, so you can use them as well. Some JDK fonts have been removed. Before, if you use, for instance, Apache Poi to work with Word or Excel documents, some fonts were used from the JDK, and if they were not present in the JDK, they will be used from the operating system. Now they're no longer present in the JDK, and if they're also not present on the operating system, then of course you don't have a font available and you have an issue. So the solution is to make sure that you install those fonts on your operating system. One other thing that's removed is the mission control. So basically the profiling and monitoring application which you could use. I can highly recommend to look into it because you can now still download them as separate builds. I think the thing that most teams are impacted by is the removal of the Java E and Corba modules, such as JuxB, which is used by a lot of applications. One thing to keep in mind is that Java E was migrated to the Eclipse Foundation and also changed its names. So not only upgrade to the latest version, but also change the names and then use the latest version, because you see that the old names, the old packages are no longer upgraded after August 2018. So make sure you change them. So in your application, make sure you use the new imports and you use the dependencies. This is a lot of information in one table. Most interesting one is the first and the last column. First column specifies the various modules such as JuxB, JuxWS, etc. And the column on the right specifies the new artifacts that you can use for them. Glassfish doesn't have an official replacement, but you can use, or sorry, Corba doesn't have an official replacement, but you can use the Glassfish Corba implementation. Make sure that if you use JuxB or JuxWS, that you include two dependencies, one for the API and one for the implementation. With Java 17, the Nashorn JavaScript engine was removed. However, it's very simple to add support for that by simply adding the dependency. If you look at Java 16, the biggest change was that they strongly encapsulated the JDK internals. So basically, they made sure that some lower level APIs are no longer available for developers and frameworks to use. Often the solution is to upgrade your dependencies. For instance, Lombok had an issue with this, but after a few weeks after Java 16 was released, they already released a fix and we could easily use that. If there's no fix available, or you have code wrote yourself which is using those internals, there is a workaround available by specifying some compiler arguments, in this case for Maven. So basically what this does is everything that was locked down will be opened up again. It's a bit like removing a lock on a door. I don't really like it. It feels really hacky. You shouldn't do this unless it's like temporary or there's really no way to work around it, but it feels really dirty to use this. And this is also where I encountered the issues with Maven toolchains. So with Maven toolchains, you can specify in the POM which Java version of the JDK you want to use. However, if I ran this on Java 16, I got the error compilation failure, which for me wasn't really helpful because it didn't describe anything. I had no clue what to do next. So then I ran it without the Maven toolchains and I got a more descriptive error for Lombok in this case. So it clearly specifies that the compiler module does not export the processing part to the unnamed module, which basically comes back to the things that we have as a workaround where we basically opened up these things again. And if we look at the code for this, so I created some examples for this as well. So I have a Lombok broken and a Lombok fixed project where the broken one contains an older version of Java and the fixed one contains a newer version of Java. And if I run this, I can easily see that it works on Java 16 and it doesn't work, oh sorry, it works on Java 15 and it no longer works on Java 16. So let's get the correct one. So now it's running on 16. And we will see that one module will fail. The broken one and the fixed one will of course succeed because I included the fix for that. Let's see, almost finished. So here we can indeed see that it failed on Java 16, the broken one, and it was fixed on Java 16. If we run the same example on Java 15, everything should of course still run because then the internals weren't hidden away yet. So the old version of Lombok also succeeds. So let's quickly show that as well. Again, everything is being set up and we see that indeed everything passes now. So it's an easy way to show some examples. Java 17, it will be released in September. It's not completely clear what will be in there, but there are some things that are already agreed upon, such as the deprecation of the applet API. Applets are not supported already for a long time, but I heard some companies are still using them on very old browsers. So that might be a challenge in the future if it's actually removed. For the AOT and JIT compilers, basically, if you want to use features like that, you can use GraalVM, which is quite popular nowadays. So if you're interested in that, have a look at GraalVM. So after we've updated all the versions of Java, we finally made it. Maybe you have to do some application-specific things. If you have a relatively easy application, for instance, with Spring Boot, which manages all your dependencies, then the application upgrade is often relatively easy. If you have a lot of dependencies that you need to maintain yourself, or you do all kinds of code generation, it might be a little bit more of a challenge. But again, like I mentioned, really simply start doing it. Don't make really long estimates for it. I was asked to do estimates when I joined this company for the upgrade of all the applications, and I told them I will give you an estimate once I'm done because I have no clue. It could be like an hour to upgrade something, it could be multiple days, and that's actually what happened. Some applications were a breeze, really simple to update. Some others were a bit more of a challenge, and in my experience, upgrading from 8 to 11 is a bit harder than upgrading from 11 to 16 or 17. That upgrade seemed to be a bit easier, but for both goes that I think it's often overestimated. Simply start doing it, do it step by step so that you can show everyone progress, not only yourself, but also your teammates, the business and everyone, and maybe allocate some blocks of time for that. And then you're finished. You can use all those cool new features such as records and pattern matching and everything. So make that investment. You will enjoy it later. And with that, I would really like to thank you. If you have any questions, please ask them. Or if you want to ask them later again, feel free to contact me. So by that, I would like to thank you and thanks for joining, and also have a nice day and see you next time.